And I would like to invite to our virtual platform here our next speaker, our second speaker, Tony Wildish, Cloud Bioinformatics Application Architect at EBI. And I have been practicing saying that all morning because it's a bit of a tongue twister. So Tony, may I ask you to step to the podium?
Hi, can you hear me?
Thank you.
And yeah, it took me quite a while to learn that job title too. So, let's see if my slides are there. Okay, yeah, good. Migrating EBI into the cloud so far, lessons learned. So yeah, I'm the cloud architect at EBI, the European Bioinformatics Institute. So what have we done with the cloud so far? We have a lot of compute happening at the European Bioinformatics Institute, and some teams have made a few forays into the cloud. Typically, projects are grant-based with a few years of funding, 3 to 5 years, something like that. And sometimes they have a bit of money left over, so they'll do a proof of concept prototype or a small service. But there's been nothing big and sustained, where by big I mean multi-terabyte scale and sustained over a year or more. Now we want to make bigger steps into the cloud, but how? And so this is what I've come up with, some of the lessons we've learned so far. I'm doing this over the last year or so. So why do we want to go? Well, the big red flag for us is that our data is growing exponentially. It's doubling roughly every 2 years, and there's not much sign of it slowing down. The main reason for this is that European Bioinformatics Institute doesn't generate data like a physics experiment does. We simply host data from life science communities around Europe and around the world. Anybody in a laboratory or a university with a sequencer produces DNA data, they can send it to us for archiving. We give them a persistent URL to it, and they can publish that with their research. And we then promise to serve that data forever. That's basically our mission. So we don't control our input. And as you can imagine, there's an awful lot of people sequencing an awful lot of DNA out there, and it's just going faster. Another reason for moving into the cloud is that a lot of our compute is quite varied. So some of it requires things like GPUs for machine learning or high memory machines. It's not uncommon to have batch jobs which require 2 terabytes of memory to process because they need to hold an entire network graph for a DNA structure in memory. And it's very hard to utilize this sort of thing well in an HPC environment. Typically, we find that these resources are oversubscribed and underutilized. They're expensive to buy, expensive to maintain. So why do we bother to own them ourselves? Why do we not just rent them by the second in the cloud? So that's another big driver for us. Sort of workloads we have basically fall into 2 classes. There's web services where you have a web front end, somebody uploads a file, gets processed through a particular piece of software or algorithm in the background, and then the results are served back to the user for them to browse. These are not particularly demanding in terms of either compute or storage. And they're not particularly interesting to me personally. Some people find them interesting. I don't, because they don't have the scaling properties which make the cloud interesting for me. So for me, the thing I find interesting is the batch processing. You have a large number of files in, you crunch them, and you get a large number of files out. At EBI, this kind of batch processing is often periodic. For instance, triggered by an upstream release of a new version of the source data. Ensemble, one of our data sets, for instance, is released quarterly, and then there's normally a lot of downstream derivative processing that goes on from that. Individual batch jobs can be very, very CPU and data intensive. For example, metagenome assembly can require a 2 terabyte machine for anything up to a month to run. And that's the CPU runtime of the thing. 32 cores, 1 month, 2 terabytes of memory, quite intensive. Add to that, we have a lot of different pipelines and a lot of different groups in different languages. We have something like 40 research and service teams at EBI, and basically their code stacks are pretty much independent of each other, and there's an awful amount of historical legacy, and the code quality varies quite a bit, as you can imagine. So we have quite a wide variety of stuff to deal with. So just to comment on workflows, typical workflows in HPC versus cloud native. On the left, you see the sort of workflow that is quite common in an HPC center. You assume there's a large disk somewhere. You run a batch job, which consists of several steps. step 1, step 2, up to step n, and you then write the output to another large disk somewhere, maybe the same as the first one. So these are very much workflow oriented. It's oriented towards what you need to do in each of the steps, processing it all together. Leads to very inefficient use of resources because, for instance, you may have one step in the middle which requires a large number of calls and the rest don't. And that means that you have an inefficient envelope for the entire batch job using too many calls. And as I say, in particular, you feel this hurting on when you're using exotic hardware like GPUs. So if you have a batch job which uses the GPU for 10% of its runtime, then that GPU is still reserved for the entire runtime of the batch job. Very inefficient. And it's hard to scale these up. Any HPC center that has tried to do anything of any size will find that their file systems are really a bottleneck after a while. On the right, you have something more like a cloud-native workflow, although I prefer to think of it as a cloud-native data flow, because when you start taking the data flow option, the data flow view of things, you start to see things very differently, and it becomes natural to think in these ways. So data is put into an input queue and processed through the first step, comes out into another input queue, gets processed through the second step, and so on, until it finally comes out at the end. So this is much easier to make this efficient because each step is tuned to the resources it needs. You can easily scale out horizontally. So step 2, for instance, you can scale out much more if you find step 2 is slower. Sorry about that noise, we're getting a delivery. And it's much more portable to multi-cloud or hybrid cloud because there's no reason why you can't queue the data in different resources and run the steps on different clouds. So some of it can be on premises, some of it in Amazon, some of it in Google. Cost optimization. This is another issue which comes up immediately you start going into the cloud. Optimizing costs for compute is relatively easy. There are many options for this. Most clouds have things like reserved instances or spot markets or sustained use discounts. You can also go the route of using an entire virtual machine, then go into containers, then go into serverless functions. So you're really shrinking things down to just the software that you're running. And there are many tools out there for helping you optimize this. Many third-party companies offer services as well. Data is much harder. Once you put a terabyte of data into the cloud, it costs money whether you're using it or not. The standard approach to saving money with data in the cloud is to use things like tiered storage, cold archives, for instance, where you reduce your costs by 10 or 100 times for data that doesn't get used often. Unfortunately, that doesn't help us because our data is growing exponentially, and that means that half of our data is less than 2 years old. And in the academic world, that means it's continually active. So it's much harder to estimate our costs for data. Things like ingress and egress just complicate this a bit. Culture. Well, the biggest problems are always involving people, not technology. To first order at EBI, we find that everybody agrees it's a good idea to use cloud, but when it comes down to it, few people actually have the time, knowledge, or experience to do it well. We find people come up with various reasons, like they're concerned about spending real money. So it's quite common that we get asked for cloud credits, whatever they are. It's a frequent question. People are also concerned about rewriting legacy pipelines. So some of our pipelines date back 10, 15 years in the code base. We have some really quite capable pipelines written in Perl, and it's not going to get any easier if they wait, but they don't find the effort to rewrite them now. Another argument, which is actually this one's the one I consider most valid, is that if they want to write a cloud-native pipeline and they still want to run in-house on the HPC center, then you get pipelines forked. You end up with 2 versions, one for in-house and one for cloud. So one of the commonly touted ways of going to the cloud, like cloud bursting from on-premises, it sounds like a really good and easy way of getting into the cloud, but quite frankly, it's not that trivial, not when you consider things like how you maintain the code base. So knowledge, support, expertise. You do need to learn things to get into the cloud. One of the things we did at EBI, we developed an in-house training program last year, and we used this to educate up to about 200 people so far It was a one-day crash program. It should have been a two-day program, but we fit it into one day because people don't have time for a two-day course. We just gave them the basics of Docker, GitLab, and Kubernetes with a bunch of exercises. There's a URL there. Feel free to go and have a look at it and let me know if you have any questions on it. We found that this is actually a very good way of getting people started, and it actually gave us a lot of momentum going forward. This was useful. But to keep the momentum, we still need support and expertise. So we have a cloud consultants team, myself and 3 others, and we are available for consultation. People just ask us questions. We can do proof of concept prototypes for people, show them this is what you're trying to do, this is how you do it, take it away and develop it into your framework. Or we can embed ourselves in teams for larger projects. If somebody has a large project, a 2-year, 3-year project, something like this, we can give them a fraction of our time over a 6-month, 9-month, 12-month period to actually help them do the work. So that the idea, we try to do the minimum possible to transfer the expertise to those groups rather than doing it all for them and leaving them with a solution but no expertise, because then you're just gaining legacy for the future. This cloud consultants team is also responsible for things like the management level infrastructure, billing, identity access management, security policies, things like this. A lot of stuff that goes around the actual use of the cloud. Need to speed up a little bit. So porting pipelines into the cloud. The easiest way to do it is lift and shift. So you just build a cluster in the cloud that looks like an on-premises system. This is easy. It makes a lower entry point for users. It gets people used to the cloud, lets them start exploring things a bit. But it's a stepping stone to doing things better. On the other hand, it's hard to be cost effective because it doesn't exploit cloud capabilities well. This is especially true for pipelines that are classic HPC and assume a large POSIX file system. Your cloud cluster will probably sit there with a large POSIX file system, which is half the time empty and half the time full. Because of this, it's hard to actually learn anything useful and gain momentum towards properly cost-efficient solutions in the cloud if you just do lift and shift. It's a starting point, but it's not a solution in itself. Scaling up. Small deployments don't teach you much. You can put a small deployment in the cloud and you don't actually learn things about large deployments from that. To learn about a large deployment, you need to do a large deployment. You need a high scale, you need longevity, otherwise you don't start seeing the benefit of things like reserved instances, spot markets, and stuff like this. So understanding and controlling the costs itself is a long-term process. It's not just we put this thing into the cloud, we tune it, now it's cost efficient. It's something you need to revisit on a regular basis. We're finding that we get a group into the cloud, they're comfortable with it. We watch them for a month or so, and we say, this seems to be costing quite a lot. Do you need that much? We talk with them, find a solution. They go away, they work on it, and they improve it. Then we look again a month later, we realize there's something else that can be tuned. It's a long-term process. They learn how to do things better. We learn how to tune costs with them. We learn how to monitor all of the applications that we put on into the cloud. So basically, it's about establishing a culture of review and oversight to actually make this happen for the future. So access, accounting, and authorization. Who actually gets to use what resource and in what way? So at some point, you need to put in policies to prevent people from spending thousands of pounds accidentally, things like this. And how you manage these rights depends on things like group level priorities within an organization. You may want some groups who have free access to do what they want because they know what they're doing and they have to have a more free reign. You want other groups where they are doing a specific thing that's related to their biology and not so much computing expertise. So those you want to have on a tighter rein so they don't accidentally make mistakes. Basically, the bottom line we find for this is that we need an API, especially if we're doing this in a hybrid or multi-cloud environment, we need an API that describes the structure of our organization, the hierarchy, the management levels, who has what role, so that we can then use this to generate corresponding structures into the clouds. Surprisingly enough, we don't actually have this yet at EBI for historical reasons, but we're getting there. This has been quite a stumbling block for us. So to summarize, moving into the cloud is an opportunity for cultural change, and you should take this opportunity, I think, not just treat it as business as usual. You need a lot of training, and you need to make sure you get sustained effort from people. Pick your use cases carefully so that you actually learn something from each use case and not just reproduce something and spend more money elsewhere. Be careful how you actually build your organization in the cloud, otherwise you'll end up with ad hoc legacy infrastructure still in the cloud as much as you do on premises. It's just as bad. And try to take a data flow view rather than a workflow view. This basically summarizes the experiences we found so far. And I'd just like to end with a quote from Paul Virilio, which pretty much sums up the adoption of any new technology, I think. This one's particularly relevant for the cloud. And with that, thank you.